Fractions and rational expressions. This video will help you simplify fractions and rational expressions, multiply and divide both fractions and rational expressions, and finally add and subtract these things. Let's take a look here at a definition. A rational expression is a fraction that contains at least one variable in the numerator or denominator or both. So we've been working a lot with fractions before. So I gave you the fraction here, 1/2. Well, a rational expression, all that means is that we've got some sort of variable in the numerator or denominator or both. Sometimes we'll have more than one terms here, and they can get a little more complicated than this. But really, a rational expression is just a fraction. Just has a variable, at least one variable in it. Let's take a look at some examples now. And I'm going to show you some techniques that you might not be familiar with, but it's really important that you practice and learn these techniques, because later on, as we start to work with these rational expressions and they get more complicated, these techniques are going to be the best way to do it. So I don't want you to give up on your old techniques for working with fractions, but you're going to want to learn some of these new ones. And these new techniques all involve a system where we're going to start by factoring. So you can see with my explanation here of what we're going to do. To simplify a rational expression, we're going to factor first, then divide out the common factors. And so let me show you what that looks like. So over here in this fraction, what I want to do is I want to take this numerator and factor it out. Kind of a way of thinking about this is we're going to break this thing down. So if I look at the number 14 and I think about factoring that, what I want to do is I want to break it down into its multiples. One easy way to do this is use a factor tree. And so in a factor tree, what we do is we think about any two numbers that are going to multiply to give me 14 besides the numbers 1 and 14. That will not help me factor this thing. So I just look at 14 and I think about any two numbers that multiply together. Well, there aren't a whole lot here, just 2 and 7. So I take 2 times 7 to give me 14. Now I'm going to go ahead and look at these numbers and see if I could factor either of these again. Well, 2 and 7 are both prime numbers. Prime numbers meaning nothing else goes into these numbers except themselves and 1. So at this point I would say, all right, now 14 is factored. So I'm going to come up here in the numerator, and instead of writing 14, I'm going to write it as 2 times 7. Now if I look at x, if I tried to factor x, the only thing that goes into x is itself and 1. So x is also considered a prime number. So I just put a dot and put multiplied by x there. Now I'm going to do the same thing with 35. So I come over here with my factor tree. I say, all right, 35, well, 35 and 1, that doesn't help me factor this, but I think 5 times 7, that gives me 35. And now if I look at 5 and if I look at 7, those are both prime. So I'm done factoring that. So I write this as 5 times 7. And then, well, x squared, let's take a look at that one. That can be factored. Remember, if I square something, it means I'm taking this something times itself. So when I think about x squared being factored, that's just x times x. So I'm going to write that as x times x down here. All right. So what I've done now essentially is I've factored the numerator and I've factored the denominator. So now I want to go to this next step here, which is to divide out the common factors. Once I get this thing factored over here, it's easy to see what my common factors are going to be. Notice I have a 7 in common in both the numerator and denominator. So I could divide a 7 out there. And I also have a factor of x in common in the numerator and denominator, and I could divide that out there. Once I get done dividing out my common factors, all I have to do is multiply the factors that are left to get a simplified fraction here. So you notice in the numerator here, I've got 2, and I've got this crossed out 7 and a crossed out x. Well, there's no such math operation here as cross out. So with this 7, what I did when I crossed that out is I'm actually dividing those things out. So really what's left when I take 7 divided by 7 is there's a little 1 left over there. Same thing happens here when I get x divided by x. That's also 1. So every time I'm crossing these things out, I'm getting a little 1 left over. So in the numerator, it looks like I have 2 times 1 times 1, or just 2. In the denominator, 5 times 1 times 1, well, that's still just 5. But then times x, the easiest way to write that is 5x. And so I've simplified that first fraction. All right. So once you learn this technique of simplifying, it really applies to both multiplication and division. We can use almost exactly the same process here to multiply and divide fractions. So that is one nice thing about this technique. So it looks like I've given us an example here. I'm asking you to divide these fractions. Well, if you remember, we don't actually ever perform division with fractions. The reason is it's difficult. If I try to take 2 divided by 18, that's not going to work out nicely. We can, however, change this division problem into a multiplication problem. And the way we do that is right here. We skip, flip, and multiply if it's a division problem. Well, skip means we leave this fraction, the first one, just like it is. So I'm going to leave that as 5y over 2. Flip, meaning we take the reciprocal of the second fraction. So that's going to be 18 over 5y. And then multiply. Remember, we're changing this division operation to multiplication. And so what happens is, this problem here, this division problem, will have the same answer as this multiplication problem if I instead multiply by the second fraction's reciprocal. Reciprocal meaning we're flipping it over. All right. Once I have this written as a multiplication problem, I'm going to use the same technique I did up here, which is factor all this stuff out, divide out the common factors. So 5 and y, if I were to factor that, that's just going to be 5 times y. 18, well, that can break down a little bit. I can factor that. So let's come over here and do a factor tree. So I'd say, all right, maybe 2 times 9 to start. 2's prime, so I'm done there. 9 is not prime. I can factor that into 3 times 3. So in this factor tree, to get the factoring of 18, what I want to do is I want to take the end of each of these little branches. We call this a tree because it kind of has little branches here. So this would be the end of one branch. This is the end of another branch. Third branch. So these numbers here at the bottom of all my tree branches are 18 factored. So I'm going to write 18 as 2 times 3 times 3. So now I've factored the numerator. I'm going to do the same thing with the denominator. 5 times y times 2. Okay. Once I've got it factored, now I can divide out my common factors. Common factor of 5 in there. Common factor of y in there. And also a common factor of 2 in there. So it looks like what I'm left with is 9 in the numerator, 1 in the denominator. So 9 over 1, oops, 9 over 1, not 9 over 9. 9 over 1, which is actually just equal to 9, because remember, every fraction is a division problem. 9 divided by 1 is going to give me just 9. All right, let's take a look at adding and subtracting rational expressions here. And I'm going to show you again another technique for this. We're also going to use factoring to do this. We're going to start out with factoring. Then we're going to build like fractions. And build like fractions, what that means is I need to get a common denominator here. So like fractions or like rational expressions in this case, we've got to get a common denominator there. Then once we get a common denominator, I can add or subtract, and then we'll look to simplify it the same way that we did before. So I'm going to show you a technique here, a tool that we use in math, and we also use it in other subjects as well. It's called a Venn diagram. And what a Venn diagram has is it's just two circles that overlap. And this overlap here represents all the things that these two items have in common. And then the individual circles on their own represent the things that they have individually. So what I'm going to do is I'm going to create a circle for this denominator, 10x, and I'm going to have another circle for 15. And what I want to do is I want to put the factors that they have in common in the middle, and then the factors that are unique to each one in their own individual circle. Well, in order to find these common factors, the first thing I got to do is factor this out. So if I look at 10x, if I factored 10, that'd be 2 times 5 times x. So those are my factors for 10x. If I look at 15, that's just 3 times 5 when I factor that. So what I want to do is I look at these numbers or expressions here factored, and it looks like they have a 5 in common. So I'm going to write that 5 in the center. Looks like 10x still needs a factor of 2 and x out here. Those factors are unique to it, the 2 and the x. And then over here with 15, I've got the 5 already right there, but unique to 15 is the factor of 3. So that's how I would create a Venn diagram. Factor the things out, put the factors that they have in common in the overlap, and the factors that are unique to each one in their own individual circle. Once I get this Venn diagram set up here, it's going to make it really easy now to find the common denominator and also to build like fractions. So once I get my Venn diagram set up, the lowest common denominator, or LCD, is just all of these factors in the Venn diagram multiplied together. So that's going to be 2 times 5 times 3 times x. And I'll just go ahead and multiply that together. 2 times 5 is 10. 10 times 3 is 30. So my common denominator here is 30x. So up here in my fractions, what I want to do now is I want to change each of these fractions so that they have 30x as the common denominator. Well, in order to build these things up into like fractions, what I need to do, remember, is I multiply the top and the bottom of each of these fractions to build it so I become 30x. One thing you can do is you could just look and say, okay, I'm starting with 10x. I want to get to 30x. I'm going to multiply by 3. That would be my missing multiplier there. But our Venn diagram will tell us what that missing multiplier was as well. So you could look at this, and if you can see what the missing multiplier is, go ahead and do that. If not, look over here at my Venn diagram. If I look at 10x, here's the circle for 10x. What is it missing? Well, the only thing that it's missing is this 3. You can see that's the only factor that's outside of its circle. So there's my missing multiplier right there. The Venn diagram gives that to us. So what I would do up here is I go, okay, times 3 times 3. And I've already really essentially multiplied 10x times 3 down here to give me the 30x. In the numerator, I'll take 1 times 3. So that would be 3. Now let's look at 15 and we say, okay, what's my missing multiplier there? Well, let's go back to the Venn diagram. Here's 15. You know, here's what it has. What is it missing? Well, the only factors that are missing are this 2x over here. That's the only thing that's outside of the circle for 15. So that's my missing multiplier. So I'd come up here and say times 2x times 2x. And as expected, 15 times 2x is going to give me 30x. And then in the numerator, 2 times 2x will give me 4x. Now that I've got a common denominator with these fractions, rational expressions, since one of this has a variable in here. Now that I have a common denominator with these rational expressions, I can go ahead and subtract them. And remember that when I add or subtract fractions, or in this case rational expressions, the denominator stays the same. So I know my denominator is going to be 30x. Now I would look at the numerators to subtract. Well, 3 minus 4x is what I have there. Now, in math and in life, we can only add or subtract things that are the same. And a constant term here, this is what this is called, something without a variable, and something with a variable, those are not the same kinds of things. Just like if I was trying to add a pencil to a piece of paper, I would just get a pencil and a piece of paper. Same idea here with math. They got to be the same things. I can't subtract these things since they're different items. So really, this is the end of my problem here. That's the best I can do in terms of simplifying the answer to this subtraction problem. All right, let's take a moment now. You want to make sure, just as in life, when you're learning how to do something, you got to practice doing it. You can't watch me do math and learn how to do it. So what I'd like you to do now is go ahead and pause your video player, and let's answer questions 1 through 9 to the best of your ability. If you can't quite get one, that's okay. And then when you get done working these problems, go ahead and push play. And I'm going to work some of these problems. I won't work all of them, but I will give you all the answers, and I'll work the ones that I think are more difficult or areas that you might have trouble. So pause your video player, work these problems. When you get done, you can watch me do them and see how you did. Okay, so I've given you some answers here to a couple problems. If you got any mistakes on these problems, I think maybe when you watch me do these other ones, you'll realize maybe what happened here. So let's take a look at question 3. So I need to factor this all out. Start with the number 66, and so I'll come right down here and just use a little scratch work here. 66. Well, it's an even number, so I'm just going to think maybe if I cut 2 would go into any even number. So if I take a 2 into 66, that would cut it in half, and I'd be at 33 then. 33 can still get factored. That's 3 times 11. So there is the factoring for 66. 2 times 3 times 11. And then I have an m cubed, meaning 3 of these m's are going to get multiplied together. 1, 2, 3, and then just n as well. All right, let's look at 108 now. Let's erase that. 108, same idea. It's an even number, so let's cut it in half. I'll factor a 2 out of there. If I cut 108 in half, that gives me 54. Then I'm thinking 6 times 9, 2, 3, and then 9 is 3 and 3. There's a lot of factors in that one. So I'm taking the end of every tree branch anytime one of these tree branches ends. So that is all of those numbers there. So let's see, 2 times 2 times 3 times 3 times 3. And then let's see, 4 m's. I'm not going to be able to fit that on there. Let's just write it this way because I'll think about it in just a second. That's m to the 4th times n. All right, let's see what's left over here. All right, so let's look at dividing out our common factors now. 2 and a 2 will divide out. A 3 and a 3. That looks like about it for my numbers. Let's look at our m's. I have 3 of them up here, 4 of them multiplied out down here. So these will all divide out. All 3 of these will divide out, and there'll be 1 left over down here in the numerator. Since there's 3 here, 3 here, 4 there, when they divide out, you can visualize this, that there'll be 1 left over in the denominator. So I'm going to cross all of those out because I divided them out, and there'll just be 1 left down here. With the n's, they'll each divide out, and I won't have any of those left. So let's take a look and see what I have left. In the numerator, it looks like I just have an 11. In the denominator, it looks like I have 2 times 3, which is 6, and then 6 times 3, which is 18. And then I have 1 of these m's, and that's it. So 11 over 18m for that one. All right, let's take a look now at question 6. Notice in question 6, I already have a common denominator, so let's focus there. And I think this is a good way to do it, is if write down the denominator first. You know that when we add or subtract things with common denominators, the denominator doesn't change. Now what I'm going to do is I'm going to focus up here and say, okay, focusing just on the numerators now. And this looks like negative 3 minus 3. Well, negative 3 minus 3 is going to give me negative 6. So negative 6 over 5, this is a fine answer. This is an improper fraction, notice. Sometimes instructors will have you write this as 5 would go in there 1 time with 1 left over, and that's still going to be negative. So either of these answers would be fine. If we write it as an improper fraction or turn that into a mixed number. And the way I turn that into a mixed number is I divided. 5 goes into 6 one whole time with 1 left over, and I take that remainder and write it over the original divisor. All right, let's take a look at question 7. A lot of stuff to factor here. I'm just going to go ahead and start by doing that. Let's start across the numerator. 5, well, that's going to stay 5. That's prime times 1 times 18. I think we already factored 18 up here. When we factored, oh no, that wasn't a different problem. Well, when I factor 18, I'm thinking 2 times 9. Well, there's 2 times, now 9 is still prime. 9 is not prime. 9 is still a composite number. I could still factor that. So 9 is going to be 3 times 3. All right, I factored the numerator. Going across the denominator now. 6, well, that's 2 times 3. And then this 3 here, well, that's prime, so that's times 3. 25, I'm thinking 5 times 5. All right, I factored all of that stuff out. Now I'm just going to go through and divide out the common factors. It's like I got a common factor of 5 in the numerator and denominator I can divide out. A common factor of 2. And 2 common factors of 3. So this guy is going to simplify down quite a bit. It looks like what I have left in the numerator is just 1. And in the denominator I have a 5. So that simplifies down to 1/5. All right, question 8. Let's take this division problem and rewrite it as multiplication, and we do that by skip, flip, multiply. So skip meaning write the first fraction the same, change to multiplication, and then we take the reciprocal of this fraction, so it's 2 over a. Once I have it multiplication, I can just factor it out. So 4a, well, that's going to be 2 times a. 2 is just going to stay 2 since it was prime. 5 will stay 5 since it was prime. And then times a down there. So it looks to me like the a's are going to divide out, and that's it. So in the numerator here, let's give myself a little space here to write this. So in the numerator, it looks like I have 2 times 2 times 2. Well, 2 times 2 is 4. Times 2 again is 8. Denominator, just 5. So your answer here of 8/5 would have been 5. If you wanted to write that as a mixed number, that would have been 1 and 3/5 would also have been a fine answer for that. Okay, question 9. Well, question 9 here, I'm adding fractions, but I don't have a common denominator. So we need to build a common denominator. And let's go ahead and we'll use a Venn diagram to do this. 2 circles that overlap. One of these circles is for 8. One of these circles is for 6. All right, when I think about factoring 8, that's going to be 2 times 4. 2 times 4, and I can break 4 down again into 2 times 2. So my factors for 8 are 3 2's. My factors for 6 are just 2 and 3. So let's look and see what factors they have in common. Well, they have a common factor of 2, so that goes in the center. Over here for 8, we still have factors of 2 and 2. So I'm going to write those out there. Over here for 6, we still have a common factor of 3. So it looks like the LCD for these two fractions is going to be all of this stuff multiplied together. Well, we know that 2 times 2 times 2 is just 8. And then times 3, 8 times 3 is going to give me 24. So my common denominator here is 24. And again, you could have done this your old way and figured out the common denominator is 24, but this Venn diagram is going to come in handy when this stuff gets more complicated. So make sure you're practicing this Venn diagram. All right, I know that I want both of my fractions now to have a denominator of 24. So I'm going to come down here and write each of those as 24. Now let's find my missing multipliers. So for 8 here, if I look at the circles, 8 was missing this factor of 3. That's the only one it's missing. So I'm taking the top and the bottom of this fraction times 3. Well, 3 times 3 is 9, so this is going to be actually negative 9 there. Let's look at 6. If I look up here at 6, what is 6 missing? Well, it's missing a 2 and a 2, or 2 times 2, which is 4. So my missing multiplier here is 4. Well, 4 times 6 gives me 24. 4 times 5 would give me 20 in the numerator. Now, I want to take close attention, or bring your attention to this idea right here. Notice this negative sign was out in front of the fraction, and I moved it to the numerator of the fraction. All right? It's the same thing whether I write the negative here or the negative here, but there's an advantage when I write it here, because notice now when I look at my denominators, they're both 24, positive 24, and now it's real easy to see that in this numerator here I'm going to be adding a negative 9 and a positive 20 together. So being able to move this negative around in a fraction is an important skill. I can actually write the negative out front. I could write it in the numerator. I could also have written it in the denominator. They all mean the same thing. All right, once I have my common denominator now, I would say, all right, well, that's going to stay the same. Now I'm going to add the numerators. Negative 9 and a positive 20 will give me a positive 11. If you're struggling or having a tricky time with this positives and negative stuff, don't worry about that. We're going to cover that again in the next unit. But I like to give you guys a lot more information and kind of challenge you a little bit as we go. I think you'll learn better if we kind of try some of this stuff, even if we're not quite ready. So if this didn't work out for you, you're not familiar with that, don't worry. We're gonna cover that some more in the class. If it did work out for you, great. All right, go ahead and pause your video player again here. I'm going to give you some of these answers, and I'll work through a couple of these problems. When you're done working these problems, hit play to see how you did. Okay, so I've put some answers up there for you. So take a second to look at those and see how you did. Now we'll go ahead and work some of these problems. So let's start with problem 10. here. So notice I'm trying to divide, but I'm dividing mixed numbers. Well, I can't divide mixed numbers, so I need to turn these both into improper fractions. The way we do that is we work in a circle. First thing we do is we multiply there, then we take that answer and add it to the top. So here's what that looks like. 2 times 3 is 6. 6 plus 1 is 7. So this is 7 halves. And since this was a negative fraction, this is also going to be a negative fraction. And then we would say, all right, divided by, same thing here, work in a circle. 3 times 3 is 9. 9 plus 2 is 11. So 11 halves. All right, and that's also negative there. So let's turn this into multiplication. So it's negative 7 halves times 2 over 11, and that's also negative. Let's see here. So if we look at this, these are already factored. These are all prime numbers. 7 is a prime number. I can't factor that. 2 is a prime number. 2 is prime. 11 is prime. So what I'm going to do here is I'm just going to look to see if there's any common factors at this point. In my numerator, I have a 7 and a 2. Denominator 2 and 11. Well, the only factor I can divide out here is a 2 and a 2, and notice that would leave me with a negative 1 up there. So now I'm ready to multiply. If I take a negative 7 times a negative 1, that's actually positive 7. A negative times a negative gives me a positive answer. And in the denominator, looks like I have just 1 here. When I divided that out, 1 times 11 would be 11. So 7 11ths for that answer. If you weren't able to navigate the negative times a negative, no worries. We'll practice that in a little while. But if you did get that, great. Okay, question 11, same thing. I'm multiplying, but I've got this mixed number. So let's go ahead and change that one. Work in a circle. 3 times 6 is 18. 18 plus 2 is 20. So that's negative 20 thirds. Let's also write this as a fraction. Negative 6. If I write that as a fraction, all I do is I write negative 6 over 1. Anytime we want to write a whole number or an integer as a fraction, you just take that number and write it over 1. Okay, let's look and see here if we've got anything else to divide out. Well, yep, there's going to be some stuff here. So let's go ahead and take a look at our answer then. Let's go ahead and draw this out. If I factor 20, I'm thinking 5 times 4. Well, 5, and then 4 can still be factored into 2 times 2. So that's what 20 would look like. And that's going to be a negative 5 on there. And then when I factor negative 6, it will be times, let's say, negative 2 times positive 3. In the denominator, I have a 3 times 1. So let's see, I can divide out this common factor of 3 there. So let's see, across the top, negative 5 times positive 2 would be negative 10. Negative 10 times 2 would be negative 20. Negative 20 times negative 2, well, that's going to make it positive. So negative 2, 20 times negative 2 would be positive 40 over 1, which is just going to end up being positive 40. If you weren't able to navigate the negatives, don't worry. If you got a negative 40 as your answer or something like that, don't sweat it. But if you were, that's good. So there's our answer to that one, is a positive 40. All right, let's take a look at question 14. Got a whole number here. I want to write that whole number as a fraction. So let's see. So 13/6 minus, again, just write it over 1, minus 6 over 1. Notice here I'm trying to get a common denominator since I'm subtracting. So if I look at my denominators of 6 and 1, I could use a Venn diagram, but I could also see that the common denominator here is just going to be 6. I can easily multiply this times something to make it 6. So the first fraction would stay the same. Second fraction, I would multiply the top and the bottom by 6. That's my missing multiplier there, so that would be 36 over 6. Now I'm ready to subtract. When I subtract or add, denominator stays the same. So that's going to be 6, and now I'm just going to focus on the numerators. 13 minus 36. Well, if I start with 13 and subtract more than I started with, I'm going to end up with a negative number, so I know that's going to be negative. Now let's think about this. I want to say, well, how many more negatives do I have here? 36 of them versus 13. I would just come over here on some scratch work and go 36 minus 13, which is 3, 2, so that's going to be negative 23. Now, one thing that I just thought of here as I was doing this video too is that we are not using calculators on the first test. So make sure you're not plunging this thing into your calculator now, because in the test we won't be allowed to use a calculator. So make sure you're kind of reviewing and using your skills here, brushing up on these skills. All right. Let's see. One more to do here. I'll erase this scratch work now. Trying to get a common denominator here. Well, this one's kind of tricky because one denominator is 3 and one is y. Let's go ahead and use our Venn diagram. This will help us. So I'll make one circle for 3, one circle for y. Let's see, what do they have in common? Well, nothing. So this will just stay 3. This will just stay y. So my LCD here is actually these multiplied together, 3y. So I want both of these denominators to have 3y. All right, well, let's look at a missing multiplier. The missing multiplier for 3, well, if you look at 3's circle, it's missing a y. So I want to take y times y here as my missing multiplier times y times y. So that will give me y in the numerator. If I look at the circle for y, what factor is it missing? Well, it's missing a 3. So I'm going to go times 3, which would be 21. Let's see, when I add or subtract, denominator stays the same. Now on the top, I'd say y plus 21. Well, those are not like terms. I can't add a y and a 21 together, but I can write them as y plus 21. And that is the best I can do for my answer. Now, some students might think that we could factor a 3 out here to simplify this fraction. Factor a 3 out here and a 3 out there, but we can't, because in order to factor this 3 or divide this 3 out, it would have to be a factor of every single term. It would have to be a factor here, which it is, and here, which it is, but it's not a factor here. Since it's not a factor of this y, I won't be able to divide a 3 out, and that's the best answer that I can get. All right, we're done with the video now. Go ahead and work on your MathLab homework.